We're not going to try to determine the magnitude of the indicated side or angle in situations where the triangle is not specifically given to us, but rather it's given to us in text form like this. We're going to talk here about triangle PRT, and we know that P is 90 degrees, R is 57 degrees. The side R, notice the small letter R for side, is 15 centimeters, and we would like to know how long side P is. So what we do is we draw a triangle, a right angled triangle, and we do our best to make it look reasonable, but it doesn't have to be drawn to scale. So we put the 90-degree angle to be P right there, and because that is the 90-degree angle, we can see right away our hypotenuse is out here. Now we have an R of 57 degrees, so we realize that this is going to be the relevant angle in our analysis. It also says that side R is 15 centimeters. Well, the side is always opposite the angle. The side and angle opposite each other share a letter. The angle gets the capital and the side gets the small. So the 15 centimeter side must be out here. So with respect to this R value, this R angle, this side here is the opposite, and this side here is the adjacent. Well, now it just becomes a regular question. We would like to know the hypotenuse, and we realize we must be talking about sine because we're talking about opposite and hypotenuse. The adjacent is irrelevant in this question because sine is equal to the opposite over the hypotenuse. Always go back to SOHCAHTOA. So we know that sine of 57 is going to equal 15 over the hypotenuse, because that's the letter P. So sine of 57 equals 15 over P, which means 0.8387 is approximately equal to 15 over P, because that's what the sine of 57 equals. We can cross multiply. 0.8387 times P is going to equal 1 times 15, approximately, which means that P will approximately be 15 divided by 0.8387, and 15 divided by 0.8387 is approximately equal to 17.9 centimeters. One more question in this context is right here. We have triangle TUV, and in this case we know that the right angle is angle T, we know what the side U is, and we know what the side V is. So we do our best to draw this triangle. We make our 90-degree angle at T, and we realize that this is the hypotenuse. Now we're looking for the side, for the angle U. This is a capital U, so we're looking for the angle U. We put a U up here, a V down here. Since we know that U, little u, is 17 meters, we know that that goes opposite capital U like this, and we know that little v is 20 meters, that goes opposite capital V, which is here. And we now reassess and we say, since this is the relevant angle, this must be the opposite, and this side right here must be the adjacent. We ask ourselves, what is the relevant trig ratio when we are considering opposite and adjacent and ignoring hypotenuse? Well, when we're only considering opposite and adjacent, the relevant is tan, because TOA stands for tan theta equals opposite over adjacent. Coming back to our question, we say tan of U is 17 over 20, opposite over adjacent, which means the tan of U is 0.85, no, approximately this time, because that is what 17 over 20 equals. That means capital U equals the tan inverse of 0.85, and the tan inverse of 0.85 is approximately 40.4 degrees.